Okay, let's take a look at page 2 now, and we have another set of data here, which is the history of the federal minimum wage. And again, we're going from the year since 1980 and the minimum wage all the way to at least July 24th of 2009. So with the years, we didn't take it all the way down to the decimal. We just did it to the whole year. So again, in number 1, it says enter your data into the list. Use years since 1980 as list 1, minimum wage, and minimum wage as list 2. Find a good window so you can see all the data points. So again, just to show you how we do this, hopefully as you can see, if I hit stat and I go to edit, you actually saw it there for a second, I have my data points in there in list 1 and list 2. If you don't have them in there, again, pause your video for just a minute, get them in, and then unpause the video to continue. So now, since I have my data in there, so I can go ahead again, go to my y equals, oh sorry, not my y equals, but since I have some equations in there, I'm going to delete these things out because it might throw things off. So if I go second y equals, turn your stat plots on. So turn it on, make sure it's on list 1 and list 2. Go ahead and hit graph. Of course, you can start to see a few points here at the bottom. My window's not the best, so I'm going to go zoom 9. So you can start to see that almost like almost linear, but then it kind of curves here at the end. So the question will become, is an exponential model the best model, or is the linear model a better model? So if we go to our next question here, it asks you to run a linear regression test. So that's what we will do next. So if I go to my calculator, go stat, over to calculate, number 8, linear regression, a plus bx, go ahead and select it, and there, lo and behold, it gives us our slope and our y-intercept. So we can go ahead and write those down into our equation here. It does say to round 4 decimal places. So my slope was 0.1262, my y-intercept was 2.9457. We're going to do the same thing again with our calculator. Go back to it, and we're going to do exponential regression. So I'm going to go stat, calculate, 0, exponential regression. I'm going to go ahead and select that one, and there I have my A and my B. So I'm going to note those down into my answers right here, which was, again, it does say to go 4 decimal places. So 3.1364 times 1.0267 to the x power. So they actually have the x there in both of these equations. Okay. So now on number 4, it asks us to exactly explain what the A and B mean in each equation tells you about the minimum wage. So remember that A is like the starting value. So when we're talking about the starting value, basically in this case, in 1980. So in our linear equation, what we could say is something to the extent of this. The predicted, because again, we're trying to predict it using this equation. So the predicted minimum wage in 1980 is about, because we are going to be rounding here, $2.95. However, in the exponential model, I'll switch colors here, the predicted minimum wage was $3.14. So in 1980 is about $3.14. So now, part B, this is probably the most important piece. Here, when we talk about our B value right here for, this is our slope, change of y over change of x. So it's basically how much we're going by. While here, this value gives you the percentage of increase. So when we talk about the linear model, what we would be saying is the predicted minimum wage increases or goes up by about a little bit more than 12 cents, so 0.1262 cents or dollars per year. However, when we talk about the exponential model, we would be saying the predicted minimum wage goes up by, and now it's a percentage, so about 2.67% per year. All right, so now it says use your table on your calculator to predict the minimum wage in the year 2020, 2030, and 2040 according to your equations. Again, it gives you this hint how many years since 1980 are each of these years. I'm going to actually calculate that out right now. So if I subtract, this is going to be my x value for each of these. The reason why it's 40 is 2020 minus 1980 is 40 years. And this is 50 years away and 60 years away. So in my table, I'm going to look for x to be 40, 50, 60. So to get these answers right away on my calculator, what you can do is instead of entering them in all one at a time, it does say to use your table. So if I go to my y equals, I'm going to type in these specific equations. So in the first one, 0.1262 x plus 2.9457. Go ahead and scroll down to the next one. 3.1364 times 1.0267 to the x power. So I have them both in there. So now if I go to my table set, this is going to be the neat thing that you can do. I'm actually going to start it, as you can see here, at 40. And I'm going to have it go up by tens. So it actually lists 40, then 50, then 60. So it's going to give me my three answers right away. So when I go to my table, remember my first equation was my linear results, so $7.99 and $9.26 and $10.52. And then you can see it for the exponential there, $9, $11.71 and 15, looks like a 3.30, or I'm sorry, my thing's on it, 0.24, so it would be $15.24. So I just want to write those answers quickly down here. So for the linear, it was $7.99, then 10 years later it was $9.26, and then 10 years after that it was $10.52. For the exponential, but growing at a much faster rate, $9, then $11.71, and then finally $15.24. All right, that ends page 2. You can go ahead and flip to page 3.